MSD is a global biopharmaceutical that has built a 100% cloud-native data ecosystem, providing self-service for ingestion, transformation, publishing, visualization, and federated data governance in AWS. And today, we will be joined by Sandeep Muturi, Director of Human Health, IT Data and Analytics in MSD Singapore, who will share with us what a real-world journey looks like towards a future-proof data ecosystem in AWS. Hello, everyone. I am Rosalie Andico, Senior Solutions Architect at AWS. With me is Sally Bell, Global Account Manager. Thank you for joining us as we show what a modern data strategy looks like on AWS and why customers build a modern data ecosystem. We will look at migration best practices and tooling for modernization, focusing on migrating a legacy data warehouse to Amazon Redshift and Aurora. This architecture supports both high concurrency, short duration queries along with long-running aggregations. Then we will hear about MSD's journey to building a modern data ecosystem in AWS, the services that they have used, and the benefits gained from this modernization. Finally, we will share some resources to help you get started. During the pandemic, we learned that change is inevitable, and getting ourselves to respond better and leverage our data provides an advantage in the survival of our businesses. To stay relevant now and in the future, building a modern data strategy is imperative. Modernizing your data ecosystem will improve operational efficiencies, drive more informed decisions, and accelerate innovation. A modern data architecture integrates a data lake, a data warehouse, and purpose-built data stores, enabling unified governance and easy data movement. With a modern data architecture on AWS, customers can build scalable data lakes with purpose-built data services, scale at low cost without compromising performance, share data across organizational boundaries, and ensure compliance via unified data access, security, and governance, and innovate with AI/ML service to solve business challenges. So how do you build a modern data strategy? Start by modernizing your data infrastructure with AWS. Take your legacy and on-premise data stores to AWS Managed Data Services. The second step is to unify. Put your data to work by connecting everything, your data lakes, data warehouse, and all of the purpose-built data stores into a coherent system that is secure and well-governed. Then you innovate. Leverage machine learning to reimagine old processes and innovate new experiences. AWS offers broadest and most complete set of AI and ML services for builders of all levels of expertise. Our focus in this session is in how to modernize your data ecosystem. Now, what are the ways to modernize your data infrastructure? First, move to managed data services that automate provisioning, database setup, patching, backups, and high availability and disaster recovery management. Second, break free from proprietary, costly legacy databases that force vendor lock-in, have punitive licensing terms, and frequent audits. Third, modernize with purpose-built data services instead of a one-size-fits-all database and build a unified data ecosystem. Customers are at different stages of their journey. By modernizing your data strategy in AWS, you gain agility, elasticity, achieve reduced capital expenditure and operating costs such as database license fees, and improve operational efficiency by adopting fully managed purpose-built databases. AWS will work with you wherever you are on this journey. With AWS, you can modernize your data infrastructure with the most scalable, trusted, and secure cloud provider. Our core infrastructure is built to satisfy the security requirements of government agencies, global banks, and other enterprises with stringent data protection and security requirements. The modern data architecture builds on several AWS services. Central to the modern data architecture is Amazon S3, an object store for structured, semi-structured, and unstructured data that scales to exabytes, which serves as a data lake. For data discovery and integration, you can use AWS Glue. It discovers, tags, and catalogs data and provides ETL to keep data in sync across the data lake, data warehouse, and purpose-built data stores. You can modernize your existing ETL scripts to leverage AWS Glue and AWS native services such as AWS Lambda and Amazon EMR. The AWS Marketplace also offers third-party ETL solution to complement ETL requirements. Once the data has been cataloged and stored in S3, it can be queried using familiar SQL syntax with Amazon Athena, which supports ad hoc serverless queries without needing to provision servers and on a pay-as-you-go model. Structured data curated from various sources can use Amazon Redshift, a cloud data warehouse for large structured data sets that require consistent query performance, and an alternative for expensive proprietary Teradata, Oracle, and SQL Server data warehouses. Structured data that is queried by a large number of users at high concurrency and where queries return small data sets and not large aggregations can leverage Amazon RDS and Aurora managed databases. Log data, which is unstructured or semi-structured, can be searched and analyzed with Amazon Open Search Service, a managed service for log analytics. For storing key value data, where consistent single-digit millisecond performance and scalability to double-digit millions of requests per second is required, Amazon DynamoDB is appropriate. Users who require a managed service for Spark, Hadoop, or Presto for data processing and computation can consider Amazon Elastic MapReduce or EMR. A modern data architecture must support artificial intelligence and machine learning capabilities for innovating new services and insights. Amazon SageMaker is a fully managed machine learning platform in AWS with fully managed infrastructure, tools, and workflows to build, train, and deploy ML models. It supports TensorFlow, PyTorch, MXNet, and other deep learning frameworks, as well as built-in and optimized algorithms for regression, classification, forecasting, anomaly detection, and several others. You can also check out AWS Lake Formation, a service that makes it easy to build, secure, and manage your AWS data lake. With AWS Lake Formation, customers can centrally define and enforce security, governance, and auditing policies and provide self-service access to data. Now that we have talked about the components of a modern data ecosystem, let us take a closer look at two of these. One of the core components of the modern data ecosystem is Amazon Redshift. It continues to be the most widely used data warehouse in the cloud with tens of thousands of customers. Redshift delivers up to 3 times better price performance than other cloud data warehouses, and it dynamically scales to improve query speed. Redshift is the only cloud data warehouse that lets you run queries at exabyte scale against your data lake along with petabytes in your cluster. Also, it has a feature called Federated Query that allows you to query and join Amazon RDS and Aurora data. At re:Invent, we announced new and updated features for Redshift. Notable among these features are Advanced Query Accelerator or AQA, which gives customers 10 times better performance than they can find elsewhere today by leveraging the new RA3 Redshift instances. Also, sharing data between business units and with external parties in a secure, controlled, and easy way is now enabled in Redshift data sharing. Bringing AI and ML to the data warehouse, we have Redshift ML to easily create and train ML models using SQL queries, and Amazon SageMaker without moving the data and learning new tools and technology. For convenient access to Redshift, without the need to install SQL clients on customer desktop, we announced Redshift Query Editor 2.0, a web-based analyst workbench for data exploration and analysis using SQL. And for users with no data warehousing experience or with unpredictable and varying workloads, we announced Amazon Redshift Serverless. Amazon Redshift is optimized for petabyte scale and large aggregations. However, For workloads with high concurrency and workloads that are selecting, inserting, or deleting a small number of rows at a time, such as reference data or high concurrency dashboards, there is Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database built for the cloud. It has the security, availability, and reliability of commercial grade databases at 1/10 the cost. It uses a row-based architecture, and this means that Amazon Aurora can handle more concurrent queries that are less resource intensive. Amazon Aurora has up to 5 times the throughput of Community MySQL and 3 times that of Community PostgreSQL, with the ability to scale out reads to up to 15 reader replicas. It uses a purpose-built log-structured distributed storage system designed for databases with 6 copies of data, 2 copies in each availability zone to protect AZ+1 failures. This storage system provides instant crash recovery, continuous backups, point-in-time restores, automatic storage scaling independent of compute, and low latency replication. Amazon Aurora also provides advanced diagnostics in performance insights to analyze and tune the database and ML-powered database recommendations to automatically detect and diagnose performance bottlenecks and operational issues. For unpredictable or highly variable workloads, example can be a dev or a test environment or production system with low volume transactions and unpredictable spikes of high volume, there is Aurora Serverless. Aurora Serverless scales in fine-grained increments to provide you the right amount of database capacity in a fraction of a second, with up to 90% cost savings compared to provisioning for peak load. Now that we have heard about 2 of the important components in the AWS modern data ecosystem, I'd like to discuss how your data can move to this ecosystem. AWS provides a portfolio of data transfer services to help you migrate your data, whether files, database, machine images, block volumes, or even tape backups. 2 of the commonly used tools for migration are Schema Conversion Tool, or SCT, and Database Migration Service, or DMS. SCT provides proprietary database and data warehouse schemas to open source engines, and DMS quickly and securely migrates your databases and data warehouse to AWS in near real time. DMS can migrate your data to and from the most widely used commercial and open source databases. It supports homogeneous migrations such as Oracle to Oracle and heterogeneous migrations between different database platforms such as Oracle, SQL Server, DB2, or Sybase to Amazon Aurora. The source database remains fully operational during the migration, minimizing downtime. You can continuously replicate your data with high availability and consolidate databases into a data warehouse by streaming data to Amazon Redshift and Amazon S3. DMS checks migration task settings, alerts for potential issues such as unsupported data types, prevents unnecessary time-consuming runtime migration failures, and validates that all data selected for migration migrated properly. It is also essential to size DMS replication instances correctly, ensuring sufficient memory and CPU capacity not only for the replication task, but for other overheads such as operating system. The Schema Conversion Tool, or SCT, converts proprietary database and data warehouse schemas to AWS data services such as Amazon Redshift or Aurora. SCT creates a report that assesses the complexity to migrate from the source database to open source targets such as MySQL, PostgreSQL, Redshift, and Amazon Aurora, and recommends the best target engine as well as provides a detailed level of effort to complete the migration. SCT converts schema and code objects to target engine, including stored procedures and functions, scans, and converts embedded SQL statements in application code, and can also extract and migrate data warehouses to Redshift via data migration agents. Migration from Oracle on-premise or on the cloud to Amazon Redshift or Aurora is done in several steps. First, AWS recommends using schema conversion tool to convert the schema objects from the source Oracle database to the target, which may be Amazon Aurora or Redshift. Once the schemas and stored procedures have been created on the target database, leverage the database migration service to migrate and replicate the data over from the source to the target. The data migration process begins with starting a DMS replication instance. Next, you configure this replication instance to connect to the source and target databases, then select tables, schemas, and databases to migrate. Then load the data and keep the data in sync between the source and the target. You can then switch your application to the target once the data is fully synchronized. Two common patterns when migrating an Oracle database to AWS with near real-time replication are shown on the slide. In the first workflow, an on-premise system is connected over the internet to an internet gateway in an AWS VPC and then to an AWS DMS replication instance. The DMS instance migrates and replicates data from the on-premise database to Amazon Redshift or Amazon Aurora. In the second workflow, a customer has a proprietary database on the cloud on EC2 or RDS and uses AWS DMS to migrate to Redshift or Aurora. Now that you have heard about the AWS services that are building blocks of a modern data ecosystem and migration best practices and patterns, let us hear from Sandeep about his experience in building MSD's Human Health Insights engine.
Hi everyone, I'm Sally Bell, Global Account Manager at AWS, and I'm here with Sandeep Moturi, the Director of MSD Human Health IT, Data and Analytics. So thank you, Sandeep, for joining us. Can you start by telling us a little bit more about your role at MSD and perhaps about this brainchild of yours, the modern data ecosystem?
Sure, Sally. So first of all, thank you for inviting me to share our journey on how we have built a modern data ecosystem using AWS services. At MSD, I'm the Director for Human Health IT Data and Analytics, mainly responsible for enabling a data ecosystem for all our emerging markets, business stakeholders. With that, our business stakeholders can generate insights out of it for their day-to-day and strategic decision making.
Excellent. And perhaps you can also tell us a little bit more about MSD as a company and a little bit more about this tagline that we know of yours is inventing for life.
Sure, love to do that. For more than a century, MSD has been inventing to solve some of the most significant challenges to people's health and well-being worldwide. We are in the business of prescription medicines, vaccines, biologic therapies, animal health products. We share one vision and mission to save and improve lives. Our vision is to make a difference in people's lives globally through innovative medicines, vaccines, and animal health products. We are committed to being the premier research-intensive biopharmaceutical company and are dedicated to providing leading innovations and solutions for today and the future. We have our vision to share, to discover, develop, and provide innovative products and services that save and improve lives worldwide.
To save and improve lives, I really like that, and the simplicity of it. So can you take us back to the start of this transformation journey, perhaps to share some of the challenges and the objectives that you had in mind?
Yeah, sure. So at MSD, over the last 18 months, MSD Human Health Data Analytics platform has been supporting advanced data analytics by focusing on industrialized data management and self-serve capabilities. This was built on a legacy technology stack, which added more complexity, inflexibility, and latency in driving data-driven decision-making. We needed to transition to a truly cloud-native architecture to address these gaps and accelerate our analytics journey. We have seen an opportunity to use AWS data services to get to our future state and drive true business value. Quickly, we formulated the future state architecture with the help of AWS teams and started implementing the solution. We have identified good business benefits from truly cloud-native architecture. Some of those are like reduced time to market for onboarding new data assets from weeks to days, seamless availability of latest data to data community, and enabled an ecosystem that allows users flexibility to define wholeness of data, and also data cataloging for data asset transparency and end-to-end data lineage, and also improved level of accuracy, timeliness, and quality of the provision data, so that enabling the markets globally the ability to refactor their local warehouses solutions to the platform. And also finally, I would like to say, fulfilling the whole emerging demand of our business users with greater speed and accuracy.
Amazing. So great list of objectives. Can you also share perhaps some of the challenges that you faced along the way, and then also how some of the AWS services were able to help solve for those?
Yeah, sure. Here is a glimpse of what we moved from our legacy system and transformed to the new system, as you can see. We have many AWS services to get to this state. We have used so many of them. Initially, we were in a cloud-based architecture and moved to the cloud-native architecture. What does it mean? Cloud-based systems really looks like sitting on the cloud, but they are not easy to scale, and also not easy to add new features, and not easy to add new capabilities as well. Whereas cloud-native and API-driven architecture allowed us to scale the features and solutions, enabled interoperability, gave us the flexibility to adjust and move with changing business needs. Traditionally, a lot of companies have built data integration layers which are inflexible to extend, not comprehensive enough to change with ongoing business needs. That's why we developed a data ecosystem that provides flexibility to data community to define depth and breadth of data needed for different use cases via the whole concept of conform. Obviously, when you're dealing with 100+ markets like we do at MSD, it's not easy to give the data or make the data available to your users, and it's always a big challenge. So we hit the same roadblock at MSD, where in some cases the data was delayed until day -2. When we moved to AWS Cloud Native architecture, we could serve the downstream systems almost on the same day or also in the day -1 in some cases. Also, we were able to optimize the entire data flows as well. And also, I would like to touch base a little bit on the technologies tools part of it. We moved from Informatica Power Center to AWS Glue and also Matillion, a third-party ETL on AWS Marketplace. From a data storage point of view, we moved from Oracle RDS to AWS Redshift, S3, DynamoDB, Aurora. From scheduling standpoint, we moved from Autosys to Airflow.
Yeah, there's obviously a huge amount there, and that's really a significant transformation. So can we go one step deeper, and could you tell us a little bit more about the architecture and the solution stack that underpins that?
Yeah, sure, Sally, would love to do that. So architecture is the foundation for everything, and whatever we have built on top of it is on the foundational architecture. What you see here is a high-level overview of the cloud-native architecture, which we have built, which is scalable, interoperable, flexible, and cost-effective. This involves different components from ingestions to the insights layer. As you can see, we have developed in-house self-service tools to ingest data into the backbone and further getting it processed to the data hub, which includes lake, transformation, and conforming of the data. Data cataloging happens with AWS Glue crawlers, and also metadata gets exchanged with Collibra so that our business users can search required business information using the metadata. Our data analysts and data scientists have access to raw, curated, transformed, and conformed data via Data Hub built on top of Redshift. Our reporting and visualization tools sit on top of the Data Hub, enabling our business users self-service, standard, or ad hoc reporting capabilities as well. Also, advanced analytics enabled using AWS SageMaker, which is sitting on top of the Data Hub for any prediction or personalization of the use cases. And also, let me share a little bit on the AWS services we have used for data storage, data processing, and data exploration and infrastructure setup. So the beauty about this is the interoperability across the ecosystem, helping the right architectural decision making based on the different business needs.
Great. So a lot of, I'm hearing operability, flexibility, scalability, timeliness. Can you go one layer deeper into some of the business and operational benefits that you've seen from deploying this modern data ecosystem?
Yeah, sure. I'll just say one word: improved TCO, improved total cost of ownership. We see a reduction in overall cost of ownership, leading to good cost savings. Also, we have seen an overall cost reduction in licenses across multiple different tool sets compared to the legacy tech stack. Plus, We see overall productivity increase across different business personas, including data scientists. I will broadly categorize these into three categories, which is mainly agility gains, productivity gains, and also financial gains. We have seen reduced time to onboard new data sets, a faster deployment cycle, and faster insights for agility gains. For productivity gains, we have seen an increased productivity for data analysts, data engineers, and data scientists using our new data ecosystem. We have seen an overall cost reduction in licensing costs in multiple service areas in terms of our financial efficiencies.
Fantastic. Well, thank you, Sandeep, for sharing today. Really insightful, and I think a lot of great takeaways for our audience. So really appreciate your time.
Yeah, thank you, Sally, and rest of the AWS team as well.
Our pleasure.
Thank you, Sandeep, for sharing your transformation journey. Now let us look at how you can get started on your own journey. To get started with building a modern data architecture, AWS provides step-by-step self-service guides so that you can perform migrations on your own. You can also get hands-on support from AWS and partners for each step on your migration journey. The first step for migration is always the most challenging. Sometimes, organizations can get paralyzed if they can't figure out how to move every last workload. An iterative approach is what we encourage you to take. We often work with organizations to do a portfolio analysis to assess each application and build a plan for moving a short-term, medium-term, and last. This helps organizations get to the benefits of the cloud for many of their applications quicker and helps inform how to move the rest. Check out our free digital courses and learning plans to gain more confidence and hands-on experience with AWS, or attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure modern data ecosystem in AWS. You can also access exam guides to validate your technical expertise with AWS and prepare for AWS certification. Lastly, please complete the session survey and let us know what you think. That ends our session for today. This is Rosalie and Dico together with Sally Bell and Sandeep Muturi. Thank you for joining us.